today we're going to talk about what happens to area when you change one or more dimensions of a shape. Okay, so let's start with this little discovery activity. These two trapezoids are the same except for what? The height, right? The two bases are the same, but the heights are different. So using this little graph and making this the trapezoid column, and let's make this the parallelogram column and this the triangle column. So you'll need 2 sets for each one. Find out the area of this trapezoid when the height is 2 and when the height is 6. Find the area of this parallelogram when the height is 1.5 and when it's 3. Find out when it's 1, the triangle when it's 1 and 4. Okay? Take a second and do that now. If you can't remember the area formulas, look back to your notes from Monday because they were in there.
Yeah, we're recording.
Okay, so when the height is 2, what's the area of the trapezoid? 16. When the height is 6, what's the area of the trapezoid? 48. Okay? So the parallelogram, 1.5 height means what area? I'm sorry? 12 times 1.5 or 18. And for 3? 36. Okay. How about for the triangle when it's 1? 1.5 times base times height? 2. And how about if the height is 4? 8. Okay. Now, compare the change in the height to the change in the area for each one. Okay? So how much is the height changing? What are we doing to get that new height? I'm sorry, say it. Right, you're multiplying by 3. How does the area change? Multiply by 3. Right? 16 times 3 is 48. How does this one change? Yeah, well, it's double. How is this changing? Double. Okay, how about this one? Times 4 or quadruple. And this one? Times 4. Okay, so if we're changing one characteristic, okay, one dimension of our shape, it has the same impact on the area as the change we made in the dimension originally that we changed. That's different from when we were talking about similar figures, because if we had a square that was 2 by 2, okay, and a square that was 4 by 4, first of all, are they similar figures? Yeah, what's the similarity ratio? 1 to 2. Okay, so the similarity ratio is 1 to 2. What's the ratio of their areas? What's in this area? 4. What's this one? 16. 1 to 4. Because remember from chapter 7, the ratio of two similar figures' area is the square of the similarity ratio. Because what's 1/2 squared? 1/2 times 1/2. 1/4. Right. Okay. So the reason these are changing by the square is because you're changing 2 dimensions, right? Don't we have to change all the sides in similar figure? Right? All the sides have to have the same similarity ratio. We studied that over and over. You could say, oh, no, these two aren't similar because they don't share the same similarity ratio. All the sides have to be the same ratio. But here, do they have the same ratio? All the heights don't, right? And so in this one, we're changing 1 dimension. So whatever change we make to the dimension is reflected in the area. Here, we're making making changes to both dimensions. And so to figure out how the area changes, we have to square the change that we made, okay, the ratio. Okay, so take this, work on this for a minute. What would happen to the area and perimeter if I made and that used to be a triangle, but now it's a rectangle, so let's change it. Rectangle, 3 times larger. This is what I want you to do. Take a minute, guess what you think is going to happen to the area, what do you think the area will be, and then actually like make it 3 times bigger and solve. Okay, so what was your guess? What would the new area be? What would the new area be? What did you say? Did you guess? The new area. Did you guess that first? Did you guess first? But did you guess? Because what we're trying to work toward today is being able to tell what the area and perimeter is without going through the whole change the sides, multiply together. Just know without even going through the dimensions what the new area would be. So did anybody guess? Maybe take a guess?
I guess 3 times bigger.
120? Okay, good. That's pretty common. So we're guessing that the new one's 120. What's the area of this one?
40.
40, right? Base times height. What's the perimeter? 26, right? 8 plus 8, 5 plus 5, that's 26. Okay? Now, if I make a shape 3 times bigger, that's going to mean the sides are what? Which is what? 15 and 24. Good. Okay? And what's the perimeter going to be? 24 plus 24 is 48. 15 plus 15 is 30. 78. Okay? How much bigger is that perimeter than that one? 3 times bigger. Sides got 3 times bigger. Perimeter got 3 times bigger. What's the area of this shape? Yeah, it's 360. Right, it's 9 times bigger. Why is that? You have to square that difference, right? You have to square the difference. So that's 40 times 9. Okay? What would the area and perimeter be if the shape was half as big? What would the perimeter be if the area was half as big as this original one? Robert? If the shape was half as big, what would the area be?
The area of that?
Perimeter, sorry, perimeter.
Oh, the perimeter? Perimeter would be 13.
Right. What would the area be?
Area would be 10.
Right. Could you square 1/2? What's 1/2 squared? 1/4. What's 1/2? 1/4 times 40? 10. So here you're multiplying by 1/2 squared, and there you're just multiplying by 1/2. Okay? Now, going back to if I only changed one dimension, what if I told you the base was going to stay the same, but the height would double? What's going to happen to the area then?
It's going to be 4 times 1.
Is the area going to go up by 4, 2 squared? No, because we're not changing both dimensions. We're only changing one. What's the new dimension going to be? Yeah, it would just be double, because wouldn't it be 10 times 8? Right? So that would be what? 80. So if you're only changing one dimension, the change to the area is going to be the same. And if you're changing both dimensions, it's going to be the square of that change. How about the perimeter? Is it going to change? How's it going to change? Is it going to double as well? No, it's not going to double, right? Because this is going to be 10 and 10
It's gonna go
and 8
5
and 8.
and a half.
So it's going to go up from, that would be 40, 46, 36.
39.
36 from 26,
Oh yeah.
right? So it's not going to go up. It's not going to double the perimeter. All right. All right. Now let's take a look at circles because they're just a little bit different because they only have one dimension, right? Or only one measurable dimension. They're two-dimensional, but the radius is the only thing we use. All right. So find the area of the shape, right, as it is now. The area of that circle with a 6 millimeter radius. So, right, if we use pi r squared and we leave pi as itself, then the area of this would be 36 pi, radius squared times pi. How about the perimeter? Although we don't call it perimeter, what do we call it? Circumference, right? What would the circumference be? Anybody remember how to calculate circumference? Pi times diameter. What's the diameter of this circle? 12. So it'd be 12 pi. Okay? If I doubled the area, okay, what would happen to the perimeter? If I doubled the area, so what would the new area be?
Is it pi r squared?